Hello friends, welcome to TechCube Gate classes. My name is Professor Vivek Singh Rathore and I am Assistant Professor in Government Engineering College, Bilaspur, Chhattisgarh. I am dealing with Signals and Systems subject and this will be the 41st lecture of the series. And in this module, module number 7, the last module, will have its second lecture. So in the last lecture in this module, I have started DTFT, discrete time Fourier transform, which was the same as that of Z transform, but Z transform is a more generalized transform, and we can see that for discrete time signals, if we want to take Fourier transform, then this is the best tool. This is the tool which we'll be using for taking Fourier transform. So in the last lecture, we have seen some questions also, inverse DTFT also, and how we arrived at DTFT, that also we have seen. ROC, this all values we have seen. Okay. Gate pulse, triangular pulse. Okay. Now today we will see some properties of DTFT because many questions are solved by the property only. So we should see the property and then we should apply those property on in some questions. Then you can understand how we'll use. So let's get started with our today's lecture. Today's lecture will start with properties of DTFT. Properties of DTFT. Okay. So see, first property which we will be seeing is time shifting property. Time shifting property. Time shifting property is very easy. In time domain, we will shift the signal. Let's suppose f of n DTFT. It is Fourier transform only, but for discrete time signal. So you can understand I am talking about DTFT only. So f of n will give Fourier transform as f of omega. Okay. Now f of n, if it is shifted by, let's suppose minus n naught, and if we will take its Fourier transform, what we will get? F of omega e to the power, see, whatever change is in the time domain signal sign, that sign will come here to the minus j omega n naught value. Okay. If your signal is shifted towards left hand side, then and if we will take Fourier transform, what we will get? F of omega e to the power j omega n naught will get. Okay. So like this time shifting property happens. Now we'll see one question, then you can understand that how we'll going to implement it. So see, if you have been given a question, let's suppose f of n is given, u of n minus u of n minus n is given. Now you have been asked to find the DTFT, and you have to find DTFT for this signal. Now how will approach it? See, as you know, that first of all you see the signal where it is there. So u of n is, you know that u of n will start from 0 and it will go on till infinite, and u of n minus n will start from 0.9 and then it will go on. Okay. So see where you can stop. See, u of n, all samples are there till infinite, and u n minus n 9 is starting from 9 and it will go on infinite. So all samples, if it is minus, then it will cancel out each other. Only from 0 to 8 values will be existing. N is equal to 0 to n is equal to 8. This is the outcome of this type of signal. Now what we have to do? What we have to do for DTFT? See, as you know that we have seen the DTFT for gate pulse. Actually, why we have solved for gate pulse? Because those solutions will be helpful in this type of question. So as you know that you have seen the Fourier transform for gate pulse minus n to n, and what you got? You got sine of omega plus n by 2, okay. Sorry, like this not sine of omega n plus 1 by 2. Okay. And the ratio was sine, both were sine only, so we can write sine into omega into 1 by 2. Okay. So this gate pulse was having its Fourier transform like this. Now what will it have? So you can see that it is a time shifted signal for this, means this has been this signal has been time shifted, and we have got this type of signal. So what time shifted, if you'll see, then you will understand that okay, this signal, let's suppose this signal is this signal is f of n according to question. So let's suppose this signal is g of n. So what you can write, f of n can be written as g of n minus 4. Obviously this signal has been shifted to the 4 values. Okay, so see, okay, fine. This will be applicable when n will be equal to 4 and this n will be equal to plus 4. So from minus 4, if n value we are taking as minus 4, and here n is equal to 4. Okay, so from minus 4 to 4, actually it is minus n to n. So from minus 4 to 4, the values were like this. Let's suppose this was g of n. So f of n is definitely g of n minus 4, because see, if we will shift in the right hand side, we will get this. So f of n will be equal to g of n minus 4. So obviously f of omega will be equal to g of omega into e to the power minus j omega 4. Okay, and what is g omega? See, g omega, you know this value, because g omega is here. Only just you need to put n is equal to 4. So sine of omega, you can take n is nothing but 4. Okay, plus 1 by 2 is there, and in the downside sine of omega into 1 by 2 is there. So you will get as sine of omega into 9 by 2, 4 to the 8 plus 1, 9 by 2, and then sine of omega by 2. Okay, so ultimately this is there, and into multiplication this is there only, but into multiplication this sign will be there, e to the power minus j omega 4 will be there. So this will be your e to the power minus j omega 4 will be there. This will be your f of omega, what you wanted the answer. So see, the question is very easy. If you have been asked like this type of question and you need to find DTFT, you just have to know what is the Fourier transform for gate pulse, discrete time gate pulse. If you know that answer, just shift this signal, find the relation, and then you can definitely get the answer. Okay, so we'll see one more question, and we'll just like this only, just a small variation in variety is there. So we'll see one more question. Okay, okay. If you have been asked f of n is equal to, let's suppose a to the power n, and then u of n is given, and u of n minus 10 will be given. Now you have been asked to find the DTFT of this signal. Okay, so see how we can do it. What will be our approach? So see, before seeing the solution, you need to pause the video and you need to check that you are able to solve or not, and then only you should see the solution. See, f of n is given like this. It can be opened also, the brackets can be opened also, like see, a to the power n u of n is given. Okay, and now a to the power n u of n minus 10 is given. Okay, now see, a to the power n u of n is given. Okay, and now see, we can also write as a to the power n minus 10 is given, and then a to the power 10 is given. Okay, a n minus 10, so that it will be cancelled out and you will get a to the power n only, and this u of n minus 10 can be written. Now it can be written, see, a to the power n u of n is given. Okay, no problem. Here a to the power 10 is given, a to the power n minus 10 u of n minus 10, a to the power n minus 10 u of n minus 10. So obviously what you can write here is, see, a to the power n u of n can be written as 1 by 1 minus a e to the power minus j omega. And this we have seen earlier also, and here a to the power 10 is given. Now here what we can write is, as you know, a to the power n u of n is nothing but 1 minus a to the power a into e to the power minus j omega, and as this has been shifted in the time. So we can also write e to the power minus 10 of j omega, है ना? So this is the final answer which we wanted. So ultimately, I think now you must be understanding that time shifting property is what. Now one more question we'll see, so as for so that your understanding is more clear. So we'll see f of n is given, f of n, and it is given as u of n minus u of n minus 10 is given. Okay, u of n minus u of n minus 10 is given. Now you need to find the DTFT. Simple. Earlier also we have seen, but what we have seen, un minus un minus 9 we have seen the question. Now some difference is there, so we'll see what difference is there. See, let's suppose your f of n, u of f of n is nothing but this is your time domain axis, है ना? So from u to the power, from 0 it will start, from 0 it will start and it will go on till 0 1 2 3 4 5 6 7 8 9, है ना? This value. So till n is equal to 0 to n is equal to 9, overall 10 values are there from 0 to 9 values, so that in 10 it will be cancelled out and nothing values will be there, so ultimately 0 values will come. Okay, so this is your f of n is there. Okay, now see what is your gate pulse, what is your gate pulse. So let's suppose you have taken it is starting from minus n to n is there. Okay, always it is a even so minus n to n. So what we can write here is see, some values are there, we need 10 values are there, and 0 to 9 n 9 10 values won't be here, because see here n values are there and right hand side n values are there. So and n plus n 2n plus 1, so ultimately 2n plus 1 values will be there. Okay, 2n plus 1 value will be there, and total values are see total 10 values are there. If you'll put 2n plus 1 is equal to 10, so you'll get as 2n is equal to 9, so you'll get as 4.5, which is not applicable. So ultimately one values you need to sacrifice, you need not to write here. So we'll take 2n plus 1 is equal to 9 values only, 9 values only we'll see. So 2n is equal to 8 value and n is equal to 4. So ultimately we'll take as n is equal to here we'll take minus 4 and here we'll take plus 4. So see, ultimately all this this full signal, if you'll see f of n, this is let's suppose g of n is there. Okay, so what we can write, f of n is nothing but f of n, f of n is nothing but, है ना? We can write here as see this signal can be written as till n is equal to 8. What we can write here as g of n minus 4 can be written. Okay, overall f of n can be written as g of n minus 4, but one value will still be remaining. So we can write here as delta n minus 9, because see impulse signals impulse value is there, so we can write here. So completely f of n is represented by g of n minus 4 plus delta n minus 9. So g of n minus 4, obviously you know sine of omega. Okay, omega, and here we'll keep 4 plus 1 by 2. Okay, and here we'll write sine of omega into 1 by 2. So we'll write like this, e to the power minus j omega 4, this value will be there, plus delta n minus 9. See, delta n Fourier transform is 1 only, so 1 into e to the power minus j omega 9 value will be there. So this is the answer which we were searching, very easy. So see, I have told you 3 questions for time shifting property. All you can understand. See, first question definitely how we'll do time shifting and how we'll use gate pulse, I have shown you. Now I have shown you if some multiplication factors is there, how you can simplify. See, Earlier it was there a n u n minus 10. So what you have to do here, some simplification that I wanted to tell you from that question. And this question, from this question you can learn that you can, if whole of the samples will not satisfy this g of n, so you can take separate, you can separate also some samples, and you can just directly add also, no problem is that, because as you know delta n Fourier transform you know easily, and then you just need to time shift only. So it is very easy pattern to solve this type of question. Now we'll see more some second property. We have seen the shifting and time domain. So we'll see frequency shifting property also. So we'll see frequency shifting property. So see frequency shifting property. See, as you know that f of n, Fourier transform you will take, you will get f of omega, है ना? If you have shifted in frequency domain, let's suppose f of omega minus omega naught, if you have seen, and you are taking IDTFT, है ना? So what you will get? You will get f of n is there, but see whenever we will shift in the frequency domain, just opposite sign will come, e to the power j omega naught n will be there. Okay. See, in time shifting, what we were doing, n minus n naught. So we were taking j omega n naught. Here we are shifting omega minus omega naught. So that's why omega naught have came here. So this is, you can also write like this. If f of n is multiplied by e to the power j omega naught n, so it, and we are taking Fourier transform, so we'll get f of omega minus omega naught. Anywhere you can take it. So see, this is the frequency shifting property. Now we'll see one question and we'll try to understand that how we can use this property. So let's suppose that you have been asked one question. If f of n is given for you, let's suppose f of n is given 1, 2, 3, 4. This is given for you, and this is n is equal to 0 value. This is your f of n, no problem. And now you have to find the DTFT. Find the DTFT of the signal. You need to find. Okay. Okay. DTFT. Okay. Okay. But see, DTFT, so okay, it's not of our cause, because we were seeing the property. Find the IDTFT. Okay, this will be the good question. Find the IDTFT of f of omega minus pi. See, this f of n Fourier transform was having f of omega. Okay, so if you do f of omega minus pi, then what f of n and something will get IDTFT, what will get, that you have been asked in the question. So let's solve it and we'll try to understand it. See, f of omega minus pi, if we'll take IDTFT, what we'll get? We'll get obviously f of n will get, and e to the power j omega naught n. Na? So here, because sign will change, so j of pi n will get. So ultimately f of omega minus pi IDTFT will have fn e to the power j pi n. Okay, you can write e to the power j pi n means e to the power j pi to the power n, and which can be written as cos of pi plus j sin pi. है ना? Cos of pi, you know value, cos of pi, cos start will here pi by 2, pi here minus 1 value. Okay, and sin pi is 0, pi by 2 pi, it will value is 0, so it is well. So ultimately e to the power j pi to the power n will be equal to minus 1 to the power n. So ultimately your f of omega minus pi will lead to, if you will take I inverse Fourier transform, what you will get, f of n will be there and minus 1 to the power n. You know what it means? See, f of n is obviously, you know, 1, 2, 3, 4. This is your f of n, and now f of n is multiplied by minus 1 to the power n. So ultimately see, this is n is equal to 0 value, this is n is equal to 1, this is n is equal to 2, this is n is equal to 3. So ultimately for n is equal to 0, this will have value 0. So minus 1 to the power 0 is multiplied by here. So you will get 1 only. Okay, no problem. For n is equal to 1, this will have minus 1. So it will multiplied. So it will be minus 2. Then again it will have 3 only. Again for n is equal to 3, it will have minus. So minus 4 will value will be there. So this is actually f of omega minus pi inverse Fourier transform. This is your answer which has been asked in your question. So see, if you have been given f of n and you need to find some Dtft of some f of omega minus pi by 2 something value, so it's very easy. Just you need to do like this, and then you can check the values and just multiply it, you'll get the answer. So it's very easy. So see, one conclusion also we can draw from here. See, when your Dtft, f of omega is what? F of omega is Dtft of f of n, है ना? If f of n is if Fourier transform has been taken of f of n, you will get f of omega. So f of omega is nothing but Dtft. So if Dtft of f of n is shifted by how much it is shifted? Pi, है ना? Pi it has been shifted. Total time period is 2 pi. As you know that any signal when we are taking Dtft, so the f of omega is continuous and it's periodic and with period 2 pi. We have seen earlier also, in the last lecture also we have seen that whenever we will draw f of omega, it will be like this. Okay, means every magnitude will repeat after 2 pi period. Okay, so this has been shifted by half of the period, half of the period it has been shifted. So you can see that reversal time, sign reversal you have seen in the odd place. 1 is as it is, 3 is as it is. Only for n is equal to 1 there is reversal, for n is equal to 3 there is reversal. So this conclusion you can note down, because in competitive exam you can directly answer that whenever Dtft of f of n is shifted by half of its time period, then what will happen? Whatever its Dtft value will be there, its value will have a sign reversal at odd values. At odd values there will be a sign reversal. Now we'll see one more property, that is multiplication by n. Okay, so we'll write here third, multiplication by n. See, when we were talking about continuous time domain, we were seeing multiplication by t. Here we will see multiplication by n because it is in discrete time domain. So let's see, as you know that f of n Fourier transform is nothing but f of omega. Okay, f of omega. So whenever we will do multiply n into f of n, what we will get, and we will take Fourier transform, what we will get? J into df by d omega. Okay, just whatever f of omega will be there, just differentiate it and then j multiplication will get. Its opposite also you can tell that differentiation in the frequency domain. So what will happen if f of omega inverse Fourier transform is f of n, then df by d omega what will be there? So it will be n by j, n by j will be there and f of n will be there. So like this it will happen. Okay, so we'll try to understand by solving one question. Okay, so see, a signal, let's suppose f of n is there, its Dtft is given 4 minus 2 e to the power minus j 2 omega. Okay, let f of n be a signal and its dtft is 4 minus 2 e to the power minus j 2 omega. Then tell me that n into f of n minus 2 will f of n minus 2 its dtft, its Fourier transform will be what? So see, you can understand that here two properties will come, multiplication by n and shifting by 2. So we'll try to solve this question. You can pause the video and you can try by yourself. So see, f of n minus 2, f of n minus 2 Fourier transform will have f of omega into e to the power minus j 2 omega. Okay. Now see, you can do it. See, f of omega, you know that this is f of omega. You can put 4 minus 2 e to the power minus j 2 omega into e to the power minus j 2 omega. So you can write it as 4 e to the power minus j 2 omega minus 2 into e to the power minus j 4 omega. Okay. Now see, this is the Fourier transform for f of n minus 2. This is the Fourier transform for f of n minus 2. If you will do n into f of n minus 2, what will happen? Obviously, you will do j df by d omega. What is df? Here is this one, 4 e to the power minus j 2 omega minus 2 e to the power minus j 4 omega. You will get the answer. Like see, j is there, d by d omega you will do. So what you will get? 4 is here only, minus j 2 will come in front, e to the power minus j 2 omega will be there, minus 2 will be there, here minus j 4 will come, e to the power minus j 4 omega will come. Now we'll see j minus 8 j will be there, e to the power minus j 2 omega minus plus 8 j will be there, e to the power minus j 4 omega. And then you can do it. See, j square is minus 1 minus plus 8 e to the power minus j 2 omega, and here j square minus 1, so minus 8 e to the power minus j 4 of omega. So it's very easy to calculate. See, you can understand that what n into fn property be like. So only you need to multiply j and df by d omega, you will get the answer. So this property, I think you can understand very easy. Now we'll go for our next property. Next property is convolution property. So we'll see convolution property. Okay, convolution property. Convolution property, as we have seen in the every domain, Laplace also, Z also. Okay, we have seen in second module also we have seen convolution. So convolution property says that if f of n Fourier transform is nothing but f of omega, है ना? And let's suppose your impulse response h of n Fourier transform is nothing but h of omega will be there. Okay, h of omega. So whenever if you are convolving your signal, if you are taking output, so you need to convolve f of n and h of n, and this is similar to if you take Fourier transform, this is similar to multiplication in the frequency domain. Means in the time domain, if you are convolving two signals, it is similar to the multiplication in the frequency domain. It is very easy. Okay, if you need to find the transfer function also, what you need to do, see, transfer function is nothing but output by input. So you will get output by input as f of omega will be there. Okay. So I will ask you one question and we'll understand this property also. We'll try to see this property. See, you have been given f of omega, let's suppose 1 by 1 minus a e to the power minus j omega square. This question is this is given in their question. Now you have to find the Dtft. Dtft. Okay. So see, f of omega is there, 1 by 1 minus a e to the power minus j omega square. You need to find the Dtft, means f of n, somewhere n values are you need to find. So see, f of omega can be written as 1 by 1 minus a e to the power minus j omega multiplied by 1 by 1 minus a e to the power minus j omega, because it was square. As you know, the multiplication in the frequency domain will lead to convolving in the time domain. Okay, no problem for that, because we need to find the value in the time domain only. Okay, so see, this is similar to, this can also be written as, see, its IDTFT value is this one IDTFT value is nothing but a to the power n u of n. If you will take a to the power n u of n DTFT value, you will get 1 by 1 minus 𝐻𝐸, and this is similar to convolving. So a to the power n u of n. So ultimately, see, multiplication in the frequency domain will lead to the convolution in the time domain. Both are similar only, no problems there. So ultimately, see, this is the this is you can tell that this is your answer for this type of question. But you need to solve also. So what you will do, see, two signals are there, and you need to do convolution. So you know that when convolution property says that whenever we'll do convolution by for two signal, what you will get, k is equal to minus infinite to infinite. We will take f of k and h of n minus k, है ना? When two signals are there like this property you have already we have studied. So here also what we will do, if we will take convolution, so we will take k is equal to minus infinite to infinite, a to the power k will be there, u to the power k will be there, a to the power n minus k will be there, and u n minus k will be there. Okay, like this will come. Now you can take common. See, a to the power n can be taken outside, so you'll keep k is equal to minus infinite to infinite value, and we'll get a to the power see, a to the power k and a to the power k is cancelled, a n is outside, so you'll get u k and u of n minus k values you will get. And you know, this value can be written as a to the power n. You can write here as k is equal to 0 to n, and the value will be 1 only. So you can write like this, and this can be written as, see, a to the power n is there, and you'll plus every values. So till n values you have to plus, so you'll get n plus 1 value. Okay, so see, final answer will be your what you were expecting. You are expecting f of omega is given, and you need to find the IDTFT value. Means in the time domain you need to find the value. You have found the value in the time domain. Okay, and see, this is your answer. You can write here un also. This is your answer. So we are doing inverse, as it is easy way actually. If you will calculate f of omega, and then from formula if you will calculate, it will go for tough and tough. Means it will take time. But if you will go for like this, you will use property. See, properties are, because properties are there for your easy only, for making your task easy only. So as long as you remember the property, you can solve the questions very easily. Now we'll see one more property. Okay, we'll see one more property, that is area property. This all property we have seen already in the Fourier transform also, but we are seeing here also, because some values may be changed for discrete and continuous time. So we'll see area property also. Area property. Area property says that, see, as you know that f of t Fourier transform is nothing but f of omega, है ना? And whenever if you will see formula, f of omega is nothing but minus infinite to infinite is there, f of t e to the power minus j omega t dt value. This is the formula for calculating the Fourier transform. See, for omega is equal to 0, if you want to calculate for omega is equal to 0, what you need to do, just integrate f of t dt. This is your area property. See, area we are taking of f of t, and what we are getting, the value at omega is equal to 0. And whenever we need to find, see, for f of t, if you need f of t, what you need, 1 by 2 pi in minus infinite to infinite f of omega e to the power j omega t d omega. So whenever for t is equal to 0, if you need f of 0 value. So what you will get, 1 by 2 pi minus infinite to infinite f of omega d omega. This is the in frequency. If you will take area, you will get 2 pi into f of 0 value, like this in the time domain also. So see, this we have seen in the time domain, continuous time Fourier transform. Now see, for discrete time, what will happen? If you need f of 0 value, what you need to do? Just replace integration by the summation. So n is equal to minus infinite to infinite, f of n value will be there. Okay. Now you understood that. See, for f of omega, omega is equal to 0 value, what you need to do, just integrate all the f of n values, simple, like that of same as that of your continuous time Fourier transform. If you need for this at t is equal to 0, f of 0 you need, so what you need to do, see, 1 by 2 pi value will be there, 1 by 2 pi value will be there, here value, see, as you know that your DTFT is periodic. So we'll not take minus infinite to infinite because it is periodic. So we'll take one period minus pi to pi value f of omega d omega. So see, the difference between continuous time Fourier transform and discrete time Fourier transform, because as GTFT is periodic, so this value will be changed from minus infinite to minus pi to pi. So we'll see, we'll try to solve one question and we'll try to understand what it says. So we'll see one question. See, f of n, let's suppose not f of n, we'll see one question is there, summation n is equal to 0 to infinite value, n into half of n. You need to calculate this value, evaluate the value, okay, evaluate the value, okay. So how you'll do, what will be your approach? See, uh, this value n is equal to 0 to infinite, because see, we are not having any formula for calculating n is equal to 0 to infinite, and you can see that anything starting from 0 to infinite, it is same as, we can write like this also, n is equal to minus infinite to infinite, n into half of n into u of n. This also you can write, because see, u of n will ultimately lead to n is equal to 0 to infinite only, no problem with that. So now your f of n value is like this. Now you need to evaluate the value. Okay. So see, DTFT value. So what we will do, as you know, that a to the power n u of n. What is the DTFT for this? So DTFT for this is 1 by 1 minus a e to the power minus j omega. Very easy. See, can you say that, see, area property says that whenever f of n is integrated from n is equal to minus infinite to infinite, you can solve from this also, or you can solve that f of omega and then omega value 0. It is very easy. Either you can solve in the right hand side, or you can solve from left hand side. Left hand side is very easy, just you need to calculate the omega, f of omega, and omega value 0. So see, let's suppose this is your n into half of nun is the your signal, f of n है ना. See, we'll calculate its f of omega and we'll keep the omega value 0. So see, a to the power n u of n is there. So we have done it like this. If we will do, a is nothing but half of n u of n. Okay. So ultimately value will come 1 minus half e to the power minus j omega. No problem for this. Okay. If we will multiply n into half of n un, then what will happen? Obviously, what we can use another property, that if we'll multiply n into f of n, so you have to do j into df by d omega. So you can do j by d omega 1 minus 1 by 1 minus half e to the power minus j omega. So this value, if you can calculate, see, we'll calculate it like, see, 1 minus half e to the power minus j omega square will come. Okay, 1 minus half e to the power minus j omega value will come 0 minus, na, 1 value will be there, and here will come minus 1 by 2 will be there, na, minus 1 by 2, and minus will come in front. Okay, and d by j will come. Okay, so here, see, this value will be cancelled. Ultimately here minus half j and j, so j square minus 1 minus 1 is plus, so ultimately half will be there. Okay, here 1 minus half e to the power minus j omega square will be there. Okay, 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 this value will be also there, e to the power half j will be there, e to the power minus j omega will be there, so ultimately e to the power minus j omega. This is your f of omega, ultimately n into half of n u of n. This Fourier transform is nothing but this value. Okay, this value is there, so this is actually f of n is there. But, and what you need to do, you need to calculate n is equal to minus infinite to infinite this f of n. So better that if you can calculate f of omega, and when omega की value 0, so f of omega is here, so you can put half of e to the power minus j 0, and here 1 minus half e to the power minus j 0 square. So what you will get, see, half will be there, it will be 1, 1 minus half will be there, and 1 minus half will be there, it will minus j 0 is 1, and its square will be there. So ultimately answer will come half value, and 1 minus half is half, and half square will be there, so it will come value is 2. So answer is your 2. Now very easy. See, if you will see this type of question, you will feel that how you will solve, this is a mathematical question, but it's very easy if you will remember the properties. Okay, so we'll see one more question, and we'll try to understand, we'll clear our concept more deeper. So see, as you know that your DTFT is periodic, is always periodic, है ना? So let's suppose if I am giving you a curve, a signal, let's say minus omega naught से omega naught, and this again it will repeat. You know that DTFT is always repeating after period of 2 pi. So see here, if it is 0, so again it will come here as 2 pi, and then it is minus 2 pi. So ultimately the values are repeating after every 2 pi period. So this is your signal. Now you need to find IDTFT value. Okay, see, now if you'll see the question, you have been given a signal, you need to find the IDTFT. So ultimately, how you'll approach? First pause the video, try by yourself, and then you see. See, as you know that for finding the IDTFT, the formula is nothing but f of n is 1 by 2 pi. You need to calculate for only one period, that is minus pi to pi only. If you calculate, then it's okay. F of omega e to the power j omega n d omega. This is the formula for finding the IDTFT value. See, 1 by 2 pi is here only. Minus pi to pi is here. Minus pi to pi. See, the values are minus omega naught, so omega naught. So you can write here minus omega naught. Okay, minus omega naught to omega naught value. And what is from minus omega to naught to omega naught? The magnitude is 1. So you can write here f of omega naught. F of omega is nothing but 1 e to the power minus e to the power j omega n d of omega. Now see, the calculation suggests that 1 by 2 pi is there, 1 by 2 pi, and then what we can do, e to the power j omega n. So here we can write here as e to the power j omega 0 n minus e to the power minus j omega 0 n, है ना? Because here minus will come. Okay, like this. Now what you can do, see, you can also divide by j and multiply it by j. Nothing will happen, no problem. Okay, so see, 2 is here only. 2 is here only. So okay, acha, I think e to the power j omega n. So value will come here 1 by jn, है ना? 1 by jn will already come. So I don't have to think like this. It will come like this only. See, integration 1 by j e to the power j omega n. So it will be e to the power j omega n by jn, है ना? And then we'll put the limits. So it will be 1 by jn. Okay. So what we can do is what we can do, 2 can be put here and n can be here, so we can write 1 by n pi, and then we can write here it as sine of omega naught n. Okay, sine of omega naught n, and this is your answer. This is your answer. So what you have calculated, see, this was your signal in frequency domain. You need to calculate it in the time domain. You have calculated it time domain, but see, for n is equal to 0, for n is equal to 0, does this value exist? It will be sine of omega 0 by 0. So it will be 0 by 0, which is indeterminate, है ना? Indeterminate. So what we can do is, है ना? What we can do is, we can apply the formula. See, as you know that that 1 by 2 pi minus pi to pi f of omega e to the power j omega n d omega a is nothing but f of n. Okay, so for n is equal to 0, f of 0 value can be calculated as 1 by 2 pi minus pi, or we can write as minus omega naught to omega naught. One value is there, e to the power j omega n d omega is there. Okay, now see, 1 by 2 pi is there. Okay. Okay, so 1 by 2 pi is here only. It can be written as 1 by 2 pi is here only, minus omega naught is there. Omega naught is there. See, e to the power j omega n, है ना? For what we are taking for n value 0. So n value here also it will come 0. So ultimately 1 will come, d of omega will come, and this will lead to 2 omega naught will come by 2 pi will come, and the answer will be omega naught by pi. So see, what I was telling you, that this value I Dtft value can be calculated like this, very easy, and this value is defined for all n value except for n is equal to 0 value, because for n is equal to 0 value it is indeterminate. So see, what we are seeing, that for n is equal to 0 value we can calculate f of 0 also. So this is your fn at n is equal to 0, and that is for different value. So I think you must have understood this property which I was telling you, area property. Now we will go on our next property. We'll go for next property. Okay. So see, that is spectral density property. Spectral density property. These all properties we have seen in the Fourier transform also, and a continuous time Fourier transform. So see, as you know that f of t Fourier transform is f of omega, है ना? How many times I have told you this only, no problem with that. If you need to find energy, what can you do? The simplest way, earlier if you have remembered, minus infinite to infinite, f of square t dt is the formula for calculating energy. Okay, and it can also be calculated in the frequency domain, like see, 1 by 2 pi can be there, minus infinite to infinite can be there, mod of f of omega square d omega. This is the value for calculating energy. So either in the time domain, either in the frequency domain, you can calculate the energy value, no problem with that. But this is in the time domain. Actually this was in the time domain. See, now for DTFT, how we can calculate energy? Energy can be calculated as summation of n is equal to minus infinite to infinite value is there, f of square n value will be there. From this value you can calculate the energy, and for frequency is the same thing, like 1 by 2 pi is there, but obviously it is in DTFT, it is periodic. So you have to take the value from minus pi to pi, and f of omega value will be there, and mod of f omega d omega. This is the energy spectral density for the formula. Okay, so see, we'll try to solve one question and we'll try to understand. Okay, so if your f of n is given in your question, like let's suppose sine 2n is given by pi n value. Okay, and this is for n is not equal to 0, and this is 2 by pi for n is equal to 0. So see, f of n value is sine 2n by pi n, n is not equal to 0, and 2 by pi n is equal to 0. Okay, so what you need to calculate? You need to calculate energy. Okay, energy. So see, by seeing the question, what will be your approach? You will first think that f of n is given something something. Now you need to calculate energy. Energy formula, first of all, your mind will click that shall I apply the energy formula? Summation n is equal to minus infinite to infinite f square n. So you'll write here energy is equal to summation of n is equal to minus infinite to infinite f of square n will be there. Okay, so can we do it? Can we do it? So see, you'll write it like this. See, n is equal to minus infinite to infinite. What is your signal? Signal is nothing but sine 2n by pi n, sine 2n by pi n, and plus for n is equal to 0, value is 2 by 0, 2 by pi. है ना? This is your f of n. You need to do square. It will take lot of time. It will take lot of time to calculate it. So better don't go with this. Go with the frequency. So energy can be calculated by frequency also. 1 by 2 pi minus pi 2 pi is there. F of omega mod value square is there. D omega, just this much only. So 1 by 2 pi is there. The value is minus pi to pi we can put here. So minus pi to pi value is there. Okay. Okay, see, for finding the limit, how we can do it. See, sine 2n by pi n. Actually, here it is not given, so you can calculate from here. See, here we were doing sine of this value was there, है ना, minus omega to omega naught, and what answer was coming? Sine omega naught n by n pi n. Now also question was asked sine 2n by pi n. So ultimately omega naught की value is 2. So we can plot here as this value sine of 2n by pi n, this value like this, this value will be maybe like this, and value will be minus omega naught to omega naught. So minus 2 say plus 2. So we can also write as minus 2 say plus 2 value, and value will be 1 only. So 1 value will be there, d of omega. So ultimately 1 by 2 pi will be there, into 4 will be there. Okay. So what we'll do? 2. So 2 by pi joule will be there. Its answer. Very easy. No problem with that. If you know the early questions also, because from early question only we have seen this question. So it's very easy to solve. Now we'll go for another property. We are in the closing for this chapter. So we'll see another property. Have patience, and we'll see time differentiation property. Time differentiation property. Time differentiation property, what it says. See, what we need to do, we need to do in time differentiation in time domain. So if f of t Fourier transform was f of omega, as you know, okay. See, and f of n Fourier transform is f of omega only. So if you do differentiation in the time domain, see what we can do. Either we can do df by dt in time domain like this. So what you will get? You will get j omega into f of omega, if you remember. है ना. And if in discrete time domain, if you will do differentiation, so what you will do, f of n minus f of n minus 1, this is equivalent to the discrete part. Okay, so what you will get, see, I'm doing Fourier transform, Fourier transform, Fourier transform, Fourier transform. So what you will get, so what we'll get here is f of omega, and f of omega 1 e to the power minus j omega. So we can write 1 minus e to the power minus j omega f of omega. So see here, in time domain it was j omega, in frequency domain it is in discrete time domain we'll see 1 minus e to the power minus j omega. So ultimately you can also say that j omega is equivalent to, this was the frequency Fourier transform in that from time domain, continuous time, and this is 1 minus e to the power minus j omega in from discrete time domain. So it is moreover equivalent to it. If we'll see time integration property also, we can understand. See, this is time integration property. Time integration property. Time integration property. So see, if f of t, if f of t Fourier transform is f of omega is there. So if we'll do integration like minus infinite to t, f of t dt is there. Okay, so if you will take Fourier transform, what will happen? See, minus infinite to t f of t dt is equivalent to f of t convolution with u of t, as I have told you earlier also in the module 2 also I have told you. So see, what will happen, f of t ut is similar to f of omega into u of omega, है ना, and multiplication. And you know that f of omega is nothing but, let's suppose f of omega is there, and u of omega is nothing but pi of delta omega plus 1 by j of omega. This was the value for u of omega. So ultimately you can write f of omega into pi is there, f of omega into delta of omega. So you'll get f of 0 into delta of omega plus f of omega by j omega. So this is your answer for Fourier transform. Okay, so see, actually this was in the time domain, continuous time domain, which I was telling you. Just you need for DTFT, what you need to do, you need to do pi f of 0 will be there, delta omega will be there, plus f of omega will be there, and you know j omega can be replaced by 1 minus e to the power minus j omega. So this is the if you can say that f of n convolution with u of n, this will lead, and this is similar to summation of k is equal to minus infinite to infinite. Let's suppose f of k value will be there, or you can say n is equal to minus infinite to infinite, f of n value will be there. So see, what I wanted to tell you, this is the time integration property, this is time differentiation property, and this is energy spectral density property, and we have seen the area property also, and then we have seen almost convolution property, multiplication by n, and then frequency shifting, time shifting, all property we have seen, almost all property of DTFT we have seen some of the questions also. So here comes to the end of DTFT. Here comes, as long as you are solving question, you'll use this property, and try to solve as many questions as possible. So we'll from next lecture we'll start our discrete Fourier transform, which is equivalent to DTFS. That is, see, we have seen the Fourier series for continuous time earlier only. Now we'll see Fourier series for the discrete time. So from the next lecture we'll study our discrete Fourier transform, DFT, and then we'll see some of the things like what is circular convolution, and we'll see the properties of DFT. Okay, so we'll see in the next lecture. So for this lecture, this much only. Till then, tata, bye bye, see you, have a good day. Jai Hind.